continuing on from yesterday, moving into two-step equations now that have fractions, and then also talking about this technique of what's called fraction busting in order to help us be able to solve these equations as kind of another option. So as a review, when we solve a two-step equation, remember to undo. So we have two parts in a two-step equation typically. We have the coefficients and we have the constants. But remember that we're typically going to undo the constants, numbers that are not attached to the variables, before we undo our coefficients. So a little review on just how to solve a two-step equation. So something like 3x plus 7 equals -5. First, move the constant by doing an inverse operation, so subtracting 7 here from both sides. We'll get rid of the 7 there, leaving us with the 3x. Over here, -5 minus 7 is going to make -12, because it's the same sign, keep and add. Then divide by 3. And we're going to get that x is going to be equal to -4 here. Okay, for number 2, the 4 is the constant, so I'm going to move that. Even though there's subtraction in between that and the 5x, it's the 5x that's really the negative term. The 4 is really a positive here, so I'm going to be subtracting 4 first. And when I subtract 4 from 29, that gives us 25. The 5x is still negative, so I need to make sure I bring that negative down. Then divide by -5 to both sides. And we get that x is equal to -5 for that one. Number 3, again, find our constant first. Adding 10 to both sides. And here, when I add 10 to -11, those are opposite signs, so subtract, keep the sign the larger, which would make -1. Multiply both sides of our equation by 4 then. And x is going to equal -4 here. Okay, now moving on to solving two-step equations with fractions. So solve these equations with using the same techniques. Just remember the rules for combining and undoing fractions. So in this next one we have, for number 1, in this set of examples, 1/2 x plus 3 is equal to 6. So I'm going to approach it the same way. 1/2 is my coefficient, the 3 is my constant, so I'm going to undo the 3 first. 6 minus 3 is 3. And then, remembering from our one-step equations with fractions, now I have a fractional coefficient of 1/2. I'd really be dividing by 1/2 on both sides, but as we saw, what we're really going to do then is multiply by its reciprocal, which is 2/1. But 2/1 is the same thing as just 2, so here where it cancels out, we get x by itself, and over here, 3 times 2 is just going to make 6 over 1 times 1, but that's just going to be 6/1, or that's the same thing as just 6. Okay. For number 2 here, I've got 5x minus 3/4 is equal to 25/4, or 25/4. So this time my constant is the fraction, so I'm going to undo that with an inverse operation. In this case, add the 3/4 to both sides because it was a -3/4, or it was 3/4 was being subtracted, so that's why I need to add. If I add 3/4 to 25/4, well, they already have common denominators, so I can go ahead and add those. So 25 plus 3 makes 28/4. And now we get 5x is equal to 28/4. If I reduce that, well, that's 28 divided by 4 is the same, so that would be just 7. And now I need to divide by 5 on both sides. 7/5, 5 doesn't divide evenly into 7, and there's no reducing I can do there, so I'm just going to leave it as a fraction here, a reduced fraction of 7/5. Okay, number 3. Again, find my variable over here. I have a constant of -20. I have 5/2 as my coefficient. I'm going to take care of the constant first, so add 20 to both sides. Again, -10 is equal to 5/2 x. To get rid of the 5/2 here, and multiply both sides by the reciprocal of 5/2, which is 2 over 5. So now the 5's cancel here, the 2's cancel. I get just x on that side like I'm wanting. Over here, I've got 2 times negative 10, which is negative 20, over 5 times 1, which is 5. And now I can go ahead and reduce that, but again, view this as division. Negative 20 divided by 5. It does divide evenly, and that's going to give us negative 4. Okay, and then number 4, one where we have 1/4 x, so we have a fractional coefficient, we have a fraction as a constant, and it's set equal to a fraction. So lots of fractions going on in this one. So first the constant, add 2/5 to both sides. Get rid of that, give us 1/4 x is equal to, I can't add 2/5 to 4/15 without making common denominators first. So let's view what we need to do. So we need to make a common denominator. In this case, the smaller denominator can be made into the larger one. So 5 does turn into a 15 if I multiply by 3 on top and bottom. So it'll be 4/15 plus 6/15. And in total, that means it's going to make 10/15, which I can reduce. So if I reduce that down, divide both by 5 on top and bottom, it'll make 2/3 for me. Now, undo my fractional coefficient by multiplying both sides by its reciprocal, which in this case, since it was 1/4, that'd be multiplying by 4 over 1. Cancels out the 4's there, also cancels out the 1's. I get 2 times 4, which is 8, over 3 times 1, which is 3. 8/3 is a fraction that can't be reduced, so I'm just going to leave it as 8/3 then for my answer there. Okay, so approaching the problems the same way as we would with a normal two-step equation, undo constants and then undo coefficients. We just need to remember our rules for how to undo or to combine fractions when needed there. Okay, so then fraction busting. What fraction busting is a technique that is used to eliminate the fractions from the equation. So it kind of makes our equations easier because it's going to leave just integers, okay, which again are our whole numbers, either positive or negative, to make it easier to solve with, so that we're just dealing with just whole numbers then, and we don't have to worry about how to combine the fractions. So to eliminate the fractions and to do this fraction busting, we're going to multiply both sides of the equation by the first common denominator of all of the fractions in the equation. So we're basically going to look across the equation for all the fractions that are in there. Sometimes there might just be one fraction, sometimes there's multiple fractions, but we're going to multiply the entire equation, both sides, and all parts of the equation. So all, if there's 3 terms involved, 4 terms involved, 5 terms involved, every term has to get multiplied by that number. Because in order to keep the equation balanced, we have to do the same thing on both sides and to all parts of the equation. And by doing that, though, the denominators of the fractions should cancel out, and the numbers that we'll be left with will be just basically the numerator portion of things. Okay, so use fraction busting to eliminate the fractions from each equation and then solve the resulting equation. So in this first one, we have 4/5 x minus 4 is equal to 6. So I only have one fraction in this, and the denominator of it is 5. So what I'm going to do is I'm going to multiply both sides of the equation, in this case by that denominator, since I only have one fraction, which is 5. And so this first term has to get multiplied by 5, and the negative 4 also has to get multiplied by 5. On this side, I only have the one term, the 6, and so just multiplying it by 5. But here, when I multiply 5 times 4/5, that's like multiplying 5 over 1 times 4 over 5. And so what we end up noticing is that we get 20 over 5, but then when I reduce that, 20 over 5 is the same thing as just 4. And so what we can actually realize is the reason why we're doing this is it causes what's called cross-canceling to take place. Cross-canceling is a technique that we're going to practice with more next week, but this is kind of a setup for that. So the 5s, because that there are factors on the top and bottom that are the same, they can actually cancel each other out. And by doing that, it leaves just the numerator in this case. We can't forget about the x term that's there. But the idea is that the 5s will cancel here, and we'll be left with just 4x. Minus, then I still have to multiply the 5 times the negative 4, but 5 times negative 4 is negative 20. And then on this side, we get 30. So now it becomes a two-step equation that doesn't have any fractions in it. So here I can add the 20 to both sides. I get 4x is equal to 50. And then divide by 4 to both sides. Which 50 doesn't divide evenly by 4, but I can reduce by dividing by 2 on top and bottom. So if I divide by 2, I get 25 over 2, and that would be a reduced fraction that I could leave as my answer. Okay, for number 2, this time I have 3 fractions involved in my equation. I have 3/4, 8/3, and 35/3. So again, to figure out what number I want to multiply by, I have to think of the denominators, and I have to think of the first common denominator between all 3 of those fractions. Since my 2 different denominators are 4 and 3, the first common denominator between those would be 12, right? So I'm thinking of first common multiples is the idea. Not looking at smaller numbers, but looking at a larger number to be able to reduce those. So here, multiply by 12 on this side, also multiply by 12 on that side. Now when I multiply by 12, unlike this situation where I had the exact same number and 5 would cancel out with 5, like in the first example, here I have 12 that I'm multiplying to 3 over 4. When I multiply by 12 this time, it's like multiplying by 12 over 1 times 3 over 4. This time the 4 will cancel out, and I'm going to divide the 12 by 4 to leave me with a 3. So this time the cross-canceling didn't completely get rid of this number, but it reduced it. And so we divide out the common factor, which in this case is the 4, to leave us with a 3. So really what I end up with is 3 times 3 for this part of things. And so by multiplying and getting rid of the 4, and multiplying by this becomes a 3, right? So 3 times 3x gives me here 9x then. Okay. The 8/3, I'm going to multiply by 12 again. So I still have to go back and multiply by 12 to the 8/3. But the 12 and the 3 are going to reduce. The 3 we get rid of that. The 12 then, when you divide it by 3, becomes a 4. So now really it's 4 times 8, which is going to make that a 32. On this side of things, the 3 divides into the 12 and makes it a 4. And now we have 35 times 4, which is 140. Okay, and once again, now what we've done is we've gotten rid of our fractions from our equation and made a two-step equation that we can solve. Okay, so subtract the 32 first to move that constant over. Divide by 9 now. And for this one, we get that x is equal to 12. Okay, number 3. 5/6 x plus 1 is equal to negative 19/6. My common denominators this time are 6's, and so I'm going to multiply both sides by 6 in order to get that fraction busting to take place. This time, when I multiply the 6 times the 5/6, again the 6's are going to cancel, and so it's going to leave me with just the 5x plus 6 times 1, which is 6. And then over here, again these 6's are going to cancel, and so it's going to leave me with just negative 19. Solve that for x. When I subtract 6 from negative 19, remember that's going to be a same sign keep and add situation. And we end up getting that x is equal to negative 5. Okay. The last one here, number 4. Again, I have two fractions here. Both of them have denominators of 6, just like in number 3. So if I multiply the entire side of the equation by 6, both sides of the equation, that is, here the 6's cancel and leave me with just 29. Here I have 3 terms that all need to be multiplied by the 6, so it's kind of like a big distributive property. So 6 times 4x first, that's going to make 24x, no denominator to reduce that 6 down. Here the 6 and the 6 are going to cancel each other and just leave a 1x. And then we have 6 times 9, which is 54. Okay, now I have like terms on the same side, so I'm going to go ahead and combine those. And then undo my constant. And divide by my coefficient of 25. And here I'm going to get that x is equal to negative 1. Okay, so hopefully you kind of have an idea of how that fraction busting technique can be used to eliminate the fractions. It's not a necessary step. You don't have to do the fraction busting, but it's an option to be able to eliminate the fractions from your equation by multiplying by the first common denominator of the fractions that are in there to be able to reduce those down to just the numerators. Okay, so hopefully you can go now and complete the worksheet that's on the two-step equations. It's a maze problem, so I'll be posting answers later for how to complete some of those problems if you're struggling with that. Don't forget about tomorrow. Check in on Google Meet between 10 and 11 if you need help with anything that we've been doing this week. And quiz should be up on Thursday of this week. So a little review practice tomorrow of the fraction stuff we've been doing. But hopefully you've got the information to help you complete the next part of your week.